So let's just step out and play with the free roam state. Add a little bit of fun. So free roaming, what are we going to do? Well, we've got a moving function, so we move around, and we feed that moving function a look direction. So what we can do with free roam is we can set certain time intervals, and after that time interval, or that timer, we can change our look direction. So I can pick a random look direction, and then we can change it over time. Let's set up some timer variables to make that happen. So this will be variable, this will be our free roam timer, float, and we're going to have a maximum time before we need a maximum so we can check our timer against it, and then we're going to make some new decisions based on that. What I'm also going to do, we'll set that to say about every 5 seconds he changes his direction. Instead of leaving that a hard 5 seconds, it'll be pretty obvious. Every 5 seconds it'll move in direction, and it'll change the direction. We can randomize this value a little bit. So let's bring in our max range of our timer, and we'll set that to about 1.5. So somewhere between 3.5 seconds and 6.5 seconds, he's going to pick a new direction. Let's create a variable for that direction so we can store that too, because we're going to keep using that until we get our next direction. And before we do that, okay, so we're going to have a max value, and we don't want to change this. We want to just use this to add or subtract our range. Terrible naming convention here. This will be our adjusted. This is the one we're going to measure. We're actually going to use, but we're going to adjust that based on a random. It'll all come clear as I coded it. And then we need to store our look directions. So we're just going to calculate the direction. And this will be a vector 3 direction. Okay, so that's a lot of variables with some terrible naming conventions and not much sense. So what are we going to do? So we're going to be free roaming. Now currently when we're free roaming, we're just setting our desired velocity to a static. So we're now running a timer. So we're going to increment our timer. We're going to add to it time.delta time. And then we're going to check. If our free roam timer is greater than our maximum adjusted timer range, then we're going to make a decision. Well, first off, let's reset everything. So we're going to reset that back to 0, and then we're going to recalculate this value. We're finally going to use all those crazy variables I just set up. Equals. So we're going to use our maximum timer as our base. So it's definitely going to be starting at 5 seconds. We're going to add to that. What are we going to add to that? We're going to add to that a random value within our tolerance, within our maximum range. So within minus 1.5 and 1.5. Let's just save that quickly. Let's go to the documents. Look at random. Okay, we have random range. So that's what we're going to do. We're just going to calculate a random range between our minus tolerance and our positive tolerance. So let's add that. So we're going to add random range, and this is going to be minus our range and positive. Okay, so what's this line doing? We're going to calculate the time before we make a new decision. We're going to use our 5-second value, and we're going to add to that somewhere between minus 1.5 and 1.5. So this is now going to be a random value that's between 3.5 seconds and 6.5 seconds. Alright, so hopefully that clears that up. Okay, so we've fixed up all our timers and reset everything and got a new time. So what do we want to do? We want to calculate a new directional vector. We're going to give them a new direction to move in. So how are we going to do that? We could use random range again. We could just pick a new random x and a random z. Let's have a look at some of the other randoms that are available. Unit inside sphere. And we have on unit sphere. So let's just have a look at the first one here. It turns a random point inside a sphere with a radius 1. So it's going to give us a normalized vector because it's only going to have a radius or a magnitude of 1 inside this sphere. Let's see if we can imagine this. So if I have a sphere, oops, okay, I seem to have a compilation error. Oh, of course, because yeah, I've left that open. Right, let's just make Unity happy. There we go. Okay, back to our theory. So we have a sphere. We're going to pick a random point inside that sphere. So basically we're picking a random vector 3, aren't we? Anywhere inside this sphere. Could be anywhere around here, but on any of the axes too. So random unit inside sphere is going to pick a directional vector, but that could be quite small in there. What other randoms did we have? We have this one on unit sphere, on the surface of a sphere. Let's check that out. Which a random point on the surface. So back to our rough example. So if we're picking on a surface, it'll be somewhere on the surface. So that's definitely going to be a normalized value. But it's not going to be smaller than a magnitude of 1. So I'm thinking that's the way to go. On any point of this sphere is a random vector 3. Let's bring our prototype scene back. And cross-reference again. We're even using a velocity. Okay, random.onUnitSphere. That's it. That's all we need to do. So our calculated directional vector is going to be random on unit sphere. Okay, and immediately we've just asked for a random vector 3. Now instead of setting our velocity to 0 as we did for testing, we want to be moving, but we want to feed it our directional vector. So just like here, after we've done calculations, we're not setting our velocity, we're going to do our velocity setting in our moving function. And now we're going to pass to our moving function our calculated directional vector. So let's just go over it again and check what's happening. We hit the free roam state. We increment our timer. Let's just say our timer hasn't reached that point yet. So if we haven't reached that point, we're going to set it to moving at whatever random vector we've assigned here. Now actually, I notice where this is going to break immediately. The first time we fall into free roam, we don't actually have this calculated. So let's just make sure we have a value in calc.dir the first time we call free roaming. So just up in the start function, we're going to do the same thing. Alright? So as soon as we start, we're going to give this a random vector 3. So the first time we fall into free roaming, we already have a directional vector to feed to our moving. Okay? And then we start running our timer. And if our timer has increased greater than our maximum value that we've calculated, we're going to reset our timer. We're going to get a new maximum time. And then we're going to, of course, calculate a new directional vector. Alright, so let's save that out and see if it's all happening. Now, compilation errors. Bring back our view so we can see what's happening here. We've got our NPC. He's going to be, okay, he's type chasing, he's going to come towards us. So I'll set him on free roam. There we go, he's picked the direction. He's gone off. Give him 5 seconds. Or some random range. There we go. Look, within 4.5 seconds this time. Now he's made another decision, and he's fallen over, actually. What's happening there? Okay, he hasn't fallen over. He's looking up. So this calc direction, as we can see, especially if we fall, look, we're calculating on the y too. Let's try and keep that a constant so he's not looking up and down crazy like that. So, back to the script reference, back to the script. So we've got this calculated direction, we've got our directional vector 3. Now we want to modify the y, so we're not looking up and down like that. So let's take our y, and we're going to make it equal to our transform position y. Okay, so we still calculated a random x, y, and z, and then we're going to reset the y to our y. So he's only going to look forward and upright. So let's save that out. Let's just check it one more time. Go to our NPC. Compilation. Set him on free roam. And see for 5 seconds he's going to move. Don't fall off. Don't fall off. Did he fall off? I think I mucked it up. Okay, let's try that again. And I'm even going to increase the floor size, so we don't get that happening again while we're testing. So let's hit that. Oh, he's scared. Let's just set him to be running away. Okay, so we've fallen into the same problem. Okay, when we went to the start function, we've calculated a random unit on the sphere surface. So similarly, where we modified the y here, we must modify the y here. See those two lines? Exactly the same as those two lines. We just needed to add it in the start too. Alright, one final time, let's check it out. No, now we have the 1.25. What is his y? 0.7? 0.8, 0.7, that just changed. 0.8. Is it picking up on his angle? So we see, yep, the angle is always staying the same there. Okay, how can we fix this? So because he falls up and down, alright, let's just completely get rid of the whole start. And then what we're going to do as well is we're going to start our free roam timer to be greater than our maximum value. Let's just set it to something silly like 1000. Alright, so the first time he falls to free range, his time is going to be well above. Now he's a rigid body, so he's going to be settled down. So then our position y is going to remain constant. We've already declared it. Okay. run, and again he's looking up. 0.7. Fix new value. 0.8. Now, I don't want to hard code this value because that's just crazy. Alright, let's say our position. Let's use our transform forward y. Okay. Let's see what happens. Okay, a lot of humming and ahhing. I think we finally fixed that issue. I very nearly paused and stopped and restarted this video for that. But this kind of thing happens to all programmers. So I suppose it's good to see all the bumps and wrinkles happening. There we go, he's maintaining a constant now. He's just grabbing his forward y. Okay, that's awesome. I honestly can say that is awesome. That's a relief. So, just to review, we have a timer that's going, and then after that timer is set, we get a new maximum adjusted time, which is random, so it's not so guessable. And we could even up this, we could say 2.5 here, and he's going to fall off. Alright, let's just try it one more time. Like I said, we can even adjust this. So yeah, that's a random value between 1.5. There we go. Let's just jump down to 2.5 because I've increased our range. Let's go into a big one. There we have it. Now I know there was probably a lot of mumbling and fumbling in there, but there we go. We've now got our free roaming random directional check included.